Hi guys, we're going to make a little video here for your lesson on 5-5. Don't forget you're going to have to turn in your notes here for this. The only thing you have to do is actually all the math problems I'm doing, and you can submit that into Google Classroom. Okay, so today we're actually going to solve some equations that have exponents, and we're going to use logarithms and solve logarithm equations using exponents. So we're going to go back and forth here, and our goal is to solve for the variable. So when you have exponential equations, we are trying to figure out what the exponent will equal to make something true. So if the variable is in the exponent spot like this, 3 to the x equals 20, that's called an exponential equation. We're trying to figure out what x is. Or 2 to the 5x equals 64. We're going to try to figure out what the x is. Now, used to be when you're trying to get x by itself here, you'd be like, how can I get x down? You'd be like, would you take the x root? And we said no, and that's why we came up with this idea of a logarithm. So here's one of the things that you can do to solve exponential equations. The first one's called the base exponent property. You don't need to know it's by name, but basically this is what you would need to know. If the bases are the same, you can just equate the exponents. What this means is if I say that 4 to the x is 4 to the 7th, the bases are the same. So clearly x is going to have to equal 7. It's the only way that it could be true. So it's not always going to be that straightforward. I mean, sometimes it can be. You could say 2 to the 5x equals 2 to the 15th. The bases are the same. So this means that 5x equals 15 and x would equal 3. But it won't always be that straightforward. For example, let's look at this. 2 to the 5x equals 64. 2 to the 5x equals 64. Oh, I don't know how to get x by itself. But when you think for a minute, you might remember and you might not. And if you don't remember, that's going to be okay. But if I take 2 and multiply by itself quite a few times, I can get to 64. And how many times would I have to do that? Well, 2 to the 6th equals 64. So now the 64 was actually a 2 in disguise to the 6th power. And because of that, I now can say, well, if the bases are the same, then 5x would have to equal 6. You divide both sides by 5, and x equals 6 over 5, or 6/5. So if the bases are the same, you can equate the exponents. Here's another example. What about 2 to the 3x minus 7 equals 32? Well, you might not know what to do right at first because the bases don't look like the same, but can't you write the 32 as a 2? And the answer is yes. That's the same thing as 2 to the 5th. So these two equations are equivalent. But now that the bases are the same, you can let the exponents be equal. And 3x minus 7 would have to equal 5 in order for that to be true. You would add 7 to both sides. You get 3x equals 12. Divide both sides by 3, and x would have to equal 4. And if you plug that in, you would get 2. 3 times 4 is 12 minus 7 to the 5th. And doesn't that equal 32? It absolutely does. So you can solve exponentials by getting the base the same. Now, there's more than one way you can do that. You can also do something called, well, we're going to go back to that. We also could rewrite it as a logarithm. Yeah, that's what I was going to say. So this is the next strategy. First, I do want you to write this down. The same thing is true with logs. If the logs have the same base and they're equal to each other, then the number after the logs would have to be equal. So that's saying that if you have the log base 2 of 7 equals the log base 2 of x, then 7 would have to equal x in order for them to be true. They used m's and n's here. The log base a of m equals the log base a of n, and that would tell you that m would have to be equal n. So you could use it with logs as well. Okay, so one thing you can do to solve these types of problems is set the things equal to each other. Now, here's another type of strategy, and this is the one I use a lot, and it's just to rewrite it as a logarithm. If you see something and you don't know what to do, then rewrite it. If you don't know what to do, rewrite it. And if you rewrite it, it might just help you out. So if you're trying to get x by itself and you don't know what to do, because I cannot change the 20 into a 3, let's rewrite it and see what happens. Well, that would be the log base 3 of 20 equals x, which is the exponent. Now, if you want an exact answer, that actually is an exact answer. You could just leave it like that. But if they want a decimal approximation, you would use that log base button, and you can get x be approximately 2.727. Okay, so this is what we would call an exact answer, and this one is an approximate. So if you don't know what to do, if you rewrite it, it might just tell you what you need to do. Okay, well, what about this one? What could we do here? Well, we could do the rewriting. I'll show you what that would look like. You cannot rewrite until you isolate the exponent. Rewrite after you isolate the exponent. So the first thing you would have to do is divide both sides by 100. We'd have to get that exponent all by itself. You would get e to the 0.08t equals 25. Now, if you don't know what to do, you can rewrite it. Well, that would be the log base e of 25 equals the exponent, which is 0.08t. But we know the log base e is the same thing as the natural log of 25 is 0.08t. You could divide both sides by 0.08, and that would tell you what t is. So you would just type in your calculator, the natural log of 25 divided by 0.08, and you would get 40.236. So that is the way by rewriting. Now, this next strategy, though, is helpful if you know your log properties. And what this tells you you can do is you can take the log or natural log of both sides. You can only do that after you isolate the exponent. So we would still have to divide both sides by 100 first. And you would get e to the 0.08t equals 25. Now, we're allowed to take the log or natural log of both sides. Well, in this case, I'm going to choose natural log. Why am I going to choose natural log? Because e is there. If it wasn't any other number, I would pick common log, but I'm going to pick the natural log. If you take the natural log of both sides, first of all, this looks like line because you can kind of cross it out. This, we could magnet pull down, and you'll get 0.08t. See, it's a way to bring it down. Natural log of e, that's the same thing as 1. That does simplify. Equals the natural log of 25. And then you can just divide both sides by 0.08. And that's exactly what we had last time when we rewrote it. So you can rewrite, or you could take the log or the natural log of both sides. So let's try this one. I have 4 to the x plus 3 equals 3 to the negative x. So I don't know what to do. I can't really rewrite it because there's too much stuff going on. So I'm going to take the log of both sides. So I'm going to take the common log of 4 to the x plus 3 equals the common log of 3 to the negative x. What am I going to do now? I'm going to use the exponent rule to pull down my exponents. And I get x plus 3 log of 4, and that x plus 3 probably should be in parentheses, equals negative x log of 3. So what can I do here? Well, let's get my x's together, and we are going to end up factoring here. So I have, let's go ahead and distribute this. X log 4 plus 3 log 4 equals negative x log 3. Get our x's together. You would have x log 4. I'm going to add x log 3 to both sides to get all of my x's on one side, plus x log 3. And that equals, I'm going to subtract the 3 log 4 And I still don't have x by itself. But these two have an x in common. So we are going to pull out the GCF. There's an x here. So that leaves me with a log 4 plus log 3. And that is just the number. That equals the negative 3 log 4. And then to finish it up, I just divide both sides by log 4 plus log 3. And I will get x equals negative 3 log 4 over log 4 plus log 3. That's an exact answer. If you need a decimal answer, you would type this in your calculator. You would hit equals, divide by this guy in parentheses. Okay, let's try that one more time just so you could see it in slow motion. You can fast forward this if you're good. We took the log of both sides. Why would I take the log of both sides? Because I can pull the exponent down. I have x plus 3 log of 4 equals negative x log of 3. I have to figure out what x is, but there's x's in both sides. So I'm going to distribute here x log 4 plus 3 log 4 equals negative x log 3. Get your x's together. So we added this x here, x log 4 plus x log 3. We subtracted the negative 3 log 4. Factor out the GCF so we can get 1x out of that situation. And then divide both sides. So when you watch it again, hopefully you can see how we got x by itself by using log properties and some GCF factoring. That one was pretty tough. Okay, let's see what they're talking about now with logarithm equations. When you have logarithm equations and there's an x there, we're going to do simple things. We're going to use algebra. You're going to try to get it as a single log. If you can get it to be a single log, you'll be good because then you can rewrite it. Basically, you're just going to rewrite. Get it like a single log and then rewrite. So on this guy here, log base 2 of x equals 4. Well, how can I figure out what x is? Well, I have a single log. If you rewrite it, it would be 2 to the 4th equals x. And all of a sudden, you know what your answer is. Your answer is just 2 to the 4th, which is 16. So 16 will equal x. This one is a little bit trickier, but I think that will be an example we'll have here in a second. So let's try this guy. You have a single log, so you can rewrite. The base is 3, so it'll be 3 to the negative 2 equals x. What is 3 to the negative 2? Well, if you type it in your calculator, you will have to hit math 1. Otherwise, you might remember that it's 1 over 3 squared, and that would be 1 over 9. Your calculator will tell you the answer. If you hit math 1, it will change it over for you. Okay, now what happens on this guy? Well, you might end up with two answers. First thing we're going to do is we're going to write it as a single log. And we're going to remember that addition becomes multiplication. So that gives me the log of x times x plus 3 equals 1. Remember that this is the common log. We do have a base of 10. So now I can rewrite it. What is the base? It's 10. What is the power? 1. 10 to the first is x times x plus 3. Once you get here, you can distribute x squared plus 3x, get 0 on one side, and then you're going to solve this quadratic. X squared plus 3x minus 10. Can we factor it? We hope so. If I make a list for negative 10, I get 1 and negative 10, 2 and negative 5. That gives me negative 3, so I need negative 2 and positive 5. So it looks like my answers are negative 2. Oh, I'm a liar. It looks like my factors are negative 2 and positive 5. X minus 2, x plus 5. And it looks like my answers are 2 and negative 5. Well, what do I have to do here? You must check. Why do I have to check? You have to check because there are risk factors. The domain is not all real numbers, guys. If I plug in 2, will it be okay? The log of 2, that's okay. You can have a log of 2 and you can have a log of 5. But are you allowed to have log of -5? Can you have 10 to some power equal -5? No. You cannot get negative answers. So that's what we call extraneous, and you would have to throw it away. You'll check them both and you'll see it won't work. Okay, what about this guy? What happens here? Well, I have 2 natural logs and I have subtraction. Subtraction turns to division. So I'm going to change this to the natural log of 4x plus 6 over x plus 3, and that's going to equal the natural log of x. So what do I do here? Well, I have a natural log equals a natural log, so what this means for me is that 4x plus 6 must equal, over x plus 3 must equal x. Can you solve this? You can. You might not think you can, but you can. What do you hate the most? The fraction. So get rid of it. Multiply both sides by x plus 3. That gives you 4x plus 6 equals x squared plus 3x. Anytime you have an x squared and an x, you need to get 0 on one side. So we'll subtract 4x and 6, subtract 4x and 6, and we get 0 is x squared minus x minus 6. Make your list for -6 to factor. 2 and -3 will get the job done. X plus 2, x minus 3, and x equals -2 and 3. Are these answers okay? Well, this is the easiest one to check here. Can you have the natural log of -2? Nope. Can you have 3? Maybe. Let's see if that works, and you would plug it in. 4 times 3 is 12. 12 plus 6 is 18. The natural log of 18 minus the natural log of 6. Does that equal the natural log of 3? Well, it should, because 18 divided by 6 is 3, and you can check it with your calculator as well. Okay, they're also going to suggest that you can use your calculator to help you with these. If you have something that looks tricky and they suggest you use your calculator, all you would do is you would type this into your Y1 and this into your Y2. You will go to second, calculate, intersect. You'll hit enter for the first curve. You'll hit enter for the second curve. It'll ask you for a guess. Because there are 2 answers, you'll have to go move your cursor closer to the one you want. You'll have to do this process twice, and you're looking for the x values. In this particular example, they're giving you 2 values that you will find. And if you plug in the -6, you will be able to have a -6 here. Both answers should work. So if they ask you about your calculator, you're looking for the second calculate. Okay, that's it for your notes. Hopefully you can start your homework and it won't be too